Hi, and welcome back to Glassboxed, writing automated cucumber tests. This is the second video in my automated cucumber scripts titled Writing a Basic Cucumber Script. And today we are going to continue where we left off from the first video and actually write a basic script with step definitions so that our feature file will pass when we run it. So for those who haven't watched my first video, please do so before watching this, as it explains a lot of fundamental concepts on building the framework. So today we will look at understanding a little bit more about the runner class, understanding a little bit more about the feature class, actually writing a step definition to go with our feature, and then running it and seeing what happens. So let's begin. So the first thing we're going to do is just talk a little bit more about the runner class and explain in a little bit more detail. Right, so again, as explained in the previous video, but I'll go over it really quickly. What we did is we created a cucumber package, and in our cucumber package we put a cucumber runner class. We then created a features package and put that inside the cucumber package, and then put our features in our features package. That probably sounds a little bit confusing, but I'm assuming that if you just take a look at this hierarchy, it should be very self-explanatory. So in a little bit more detail, what is the job of the runner class? What does it actually do? So what it actually does is when we run a feature file, what happens is the feature effectively is looking for a runner class. It's looking for a class to help it to find step definitions somewhere else, somewhere within the project, somewhere that is defined by the runner class. So in our runner class, what we do is we first just say whenever we run this class, we run it as part of a cucumber class. So what that means is anything that's in the cucumber class, so anything that's governed, any rules that cucumber needs when it runs, is all in a sense inherited as part of this class. Don't mistake inheritance for the run with. They are two different things entirely. They're not the same, but they share similar concepts, if you like. Then what we do is we add some options which the cucumber class has. So when I say run cucumber class, it's almost a really abstract or maybe even a cheeky way of saying, because we're running this cucumber runner class with the cucumber class, almost inexplicitly we are able to use options and pass in the options to the class when it runs. So in this instance we have two different options. In essence, we don't actually need this option in order to run our framework. I just left it in there for the sake of just kind of getting the ball rolling with reporters. Probably going forward, I'll probably do a much more detailed video on reports and actually show you the various kind of reports you can generate. Sometimes reports are actually incredibly important because let's just say you're writing this just for purely personal purposes. Report might not be very important, but if you're say working on a client's base and they're interested in reports, and let's just say the reports have to be in a certain format or have to abide by certain rules, you can somewhat have a little bit of power over that here. So in this instance, we're always saying is when we run our features, just produce a JSON. But I can very well just say something like run HTML instead. There are various options. There are other report structures as well. Again, we'll go into that in a future video. The next is addressing the very first point we talked about when we run a feature file, which is when we run a feature file, where are all our features, and that's what's defined here. So this is just kind of governing the location of our features. We can do a lot more in our cucumber class. For example, we can adding things like tags, which can effectively turn a cucumber runner class almost into a cucumber suit. Again, that will require a little more explanation, and I think the focus of the moment should purely be at just trying to get everything working to a level where we are happy that everything is working. So the cucumber class actually has a lot of other features that I haven't talked about, purely because the focus of this video at the moment is just trying to get everything glued together properly. And that's pretty much it really for the cucumber class. It's not too complex or difficult to understand. You just need to grasp the idea that when I run a feature file, this class also runs, and this class effectively has these options which helps us to run our feature file. Now let's talk about the feature file. So in our last video I talked about the kind of construct of a feature file, and the construct is that it has a feature. Although this is optional, you don't have to have it, but it is most certainly one of the top advice I would give, is that have a feature, have a line that just says the feature and the high level description of your feature in that class, purely because let's just say our feature file had multiple scenarios, and scenarios can get very detailed using various things such as data tables and parameters. It can get very confusing to someone who's trying to figure out the type of tests in this feature file if something like the feature was missing. So by having a feature and then a description, it almost highlights the purpose of that feature file and almost identifies the type of tests in that feature file. So if you are going to take one thing away from this video other than building this framework, is that make sure that you have a feature keyword with a line. It doesn't run, it's almost treated as a comment when you run your feature file. It doesn't affect your test at all, but from a high level perspective, in terms of understanding what your feature file is, this is equally important as writing a scenario, I would say. So the second is scenario, right? So an easy way to explain it is, if I were to compare this to say something like JUnit. So in our JUnit, whenever we write a JUnit test, we have so when we write a JUnit test, we usually have something similar to this, where we say test, and then we say public void, the actual test method. It's something like this, and then we have the contents of our test here, followed by assertions and so on. So if we compare this, the construct of a test method for JUnit or various other testing frameworks, and we compared the cucumber scenario, what it is when we say scenario, we're effectively annotating any steps after the scenario as if it was a test. So when we say scenario, it's almost identically saying this is a test identified in a feature file. When we then say steps, so let's just say at this moment we're saying given something, when something, and then something. It's almost like saying these are the steps to the code that happen inside a JUnit test. Now a little bit more about these given, whens, and thens. So givens traditionally, well actually before I talk about it, I did mention this in my previous video. This given, when, and then keywords are completely irrelevant to the actual code that is written inside the method that the step relates to. So let me just get rid of that just to kind of stop any confusion. So as I said, the given keyword doesn't make any difference at all to how the code inside this mapped step definition would work at all. It's important you kind of know that, because this given, when, then is only there for readability purposes. It's just to make your life easier, and this is why. The purpose of a given step is usually to set the scope of a test, is set the presence of a test. So let's just say we were trying to open up a web browser, go to a website. So let's just say go to my zoo website. So if I just really quickly go to it, so here for example, so this is a web page that's effectively navigated to my zoo website, and then there's various other links and so on. The purpose of the given step is just to effectively just set up your test. It's usually not really used to do any kind of logical checks or any logical actions such as clicking on something or checking that something exists somewhere. Nothing. The given is only the presence. It's the setup. It's the introduction to the test, if you like. The when step of a scenario, or the function of this when, is to actually do something, is to perform an action. So let's just say in this case our given was go to zoo website. The when could have been something like click on adoption, for instance. The when action doesn't necessarily have to be a single action. It could be multiple actions. So let's just say it could be something like given I go to the zoo site, when I click on adoption. You can have more steps if you want. You can then have further more when steps if you like, saying something along the lines of when I click on adoption, when I click on check, so check, and so on. And the then part of the scenario, the purpose of then part is to effectively perform the check of the test. So in this instance, we could say something like check that sorry, animal not available message was displayed. So if I were to rewrite it, something along the lines of given I navigated to the zoo website, effectively setting up our test. When I click on the adoption link, so we clicked on adoption link, and we can use another construct called the end keyword. It's exactly like the given when steps. So it's something like, and I click on the check button, then I check to see that no animals are available. So in my previous video I actually was really naive with the way I wrote my steps, but now if you look at these steps a little bit more, they actually make a lot more sense. Given I am somewhere, in other words the setup, when I click on something and click on something else. So these two steps are setting up the actions or the conclusion to the step, and then the then is what actually checks to make sure that everything was checked, and if there are any assertions you would expect it to be in the then. So really quickly, taking a step back, let me just quickly discuss what AND is. AND doesn't really play any logical role in the sense of a given, when, then. Traditionally, people have the steps given, when, and then in that order. And usually can be put almost anywhere. So I can say and there, I can have an and there if I like. I can have two there if I like. It's almost building up on the previous step. If it's a when or a then. So in this case, when I do this, and I do this, and I do this, then I check for something, and I check for something. So that's the kind of construct we take. Right. So, and that's kind of my more detailed perspective on what a feature file is and the purposes and the given, and the description of these keywords. So now let's run this. Perfect. So now effectively what we're being told is that these steps are missing, in that they have been identified in a feature file, and Eclipse knows that these steps exist in a feature file, but Eclipse is also saying it was unable to find these steps. So now we're actually going to do the magic. What we're going to do is implement these steps, and this is how we do it. Usually people would just write say steps here, and then they'd instantly go and copy those steps into a step definition file. What I tend to do is I tend to be a little bit more clever about it. I just literally run my test, and then any steps which aren't found are given here, and they're usually in the format as well. They're in the format about 80% of the time. The 20% of the time is where you need to do a little bit of rejigging. So what we're going to do is we're just going to copy all of these steps. So notice for the given steps, it knows it's a given. For the when, and same for the then, again it knows. So it kind of does a little bit of handling for us. So what we're going to do is we're just going to copy these. So we've got them in our computer memory. And now what we're going to do is we're going to create a new step definitions class in the features package. So right click, new class, and give it a name. So I usually give it the name of step definitions. For the purposes of this framework anyway, if you were to build, let's just say, a larger framework, I would surely give this class a much more meaningful name. And the reason why you would give it meaningful names is because you would want certain steps to belong in certain classes. But for the purpose of this video, let's just keep it a little bit simple, and let's just say that all the steps exist in only one class. So let's finish this. Perfect. Now all you do is you paste in the steps. Now you'll get errors naturally. What you need to do is import in all the libraries using the shortcut, which I use is Ctrl-Shift-O. And now what will happen is when you run, it will find all the features, but it will throw an exception. It will throw a pending exception, which basically means that the step was found, but the step hasn't been implemented. It's something that Cucumber automatically gives us. So let's just see what happens when you actually run it without implementing anything ourselves. So we run the step, and it's basically said, I tried to run this particular step and I got an exception, and it didn't even bother running the other steps because there's no point. Because this happens in order from top to bottom, there's no point in running the other steps if the first one fails. And that's another key thing to understand about feature files. Whenever we run a scenario, so in this instance we only have the one scenario. So let's just say we had something like this. We have 3 scenarios. Just assume they're different for the moment. I know they're not, but let's just assume they are. What would happen is, let's just say in this scenario the first step fails, this fails. It won't run the other steps because there's no point. If a part of a test fails, there's no point. It won't run anything else because it makes no logical sense to run everything else. Then let's just say this was a completely different test, and this ran, and all the steps ran fine. Then that's fine. This entire scenario would count as a scenario that passed. This scenario would count as a scenario that failed. Now let's say we were running this one, and it ran the first one without any problems, and the second without any problems, and it ran the last step and it failed. This scenario would also be counted as a scenario that failed. So it's important to understand that when one step fails, every step in that given scenario fails. But to be more blunt about it, if a step fails in a scenario, the remaining steps don't even run. So I hope I've made that crystal clear. Alright, back to our step definition. So what happened? So we got an exception saying pending exception because we haven't implemented anything. So that's actually a step in the right direction, in that at least now our feature file is able to pick up the steps that we defined. So what I'm going to do is I'm just going to get rid of all this. But before I write any code, I'm going to explain what these steps actually mean. So what happens? So let me just quickly save this. Right. So what happens? Get rid of that. So when we run our feature file and it goes to this line here, effectively, it's basically saying, okay, I need to go and find the code that's implemented for this given step if it has been implemented. So it goes to the runner class. Runner class says everything's in here, go look in there, and it looks in there, and it eventually ends up in this step definitions class. And what it then does is it first looks for this keyword in the form of an annotation, and then it tries to map the string for that step in the form of a parameter passed to that annotation. So if we now look at the step definition, this is exactly what's happening here. So this given is translated into an annotation, and then this string is translated into effectively part of a regex pattern, which is then passed into the given. So here we're saying, given I navigated to the zoo website, that is directly mapped to this, and this is how the mapping is done. So this given, when, then, and the and keywords are mapped to annotations in our Java class, and the rest of the step is almost passed as a string to the annotation. And when it finds a matching annotation and a matching string, it runs the method that the annotation is marked for. So in this case, what happens is, when we run this method, or rather when we try to run this step, it tries to find a matching annotation. When it finds the matching annotation, it runs the method that the annotation is matched to. So that's the first thing, and that's almost how the relationship between a defined step in a scenario and the defined step definition in a class is. Now, one thing I did was I directly copied these steps from the error that was generated before this class existed. One of the things it does is it creates this long name. Now, there's absolutely nothing stopping you from changing it. You can make it whatever you want. Usually what Cucumber does is it tries to be a little bit clever, and it tries to name the method identical to the step, excluding the annotation. So if you like, you can keep it as is. It's completely up to you. Now naturally, if you follow kind of Java's rules, or rather OOP rules on naming things in a certain convention, then obviously this isn't probably very sensible. So what I do is I just kind of change it. So in fact, I don't even do that. I usually rename it to what I think is more sensible. So in this case, I will just call it something like should navigate to zoo. So here we're saying I click on adoption request, so I just say something like should click on adoption, and here I'm effectively going to end up doing an insertion of some means or another to check that animals are available. So I'm just going to say check animal string visible, and that's it. So now what I'm going to do is I'm just going to print out some statements just to prove that not necessarily to prove in this video, but just to prove the concept that the right steps are talking to the right methods. So in this case, I'm just say executed the navigate to zoo method. In here, I'm going to say executed the click on adoption link method, and finally I'm going to say checked that the no animals string was visible or not. Right. So now let's go back, and now let's run and see what happens. And there you go. So what happened? So first of all, if we just take a look at the summary of our test, and the summary is usually at the very bottom. It says there was one scenario in total and one scenario in total passed, and there were 3 steps, and of the 3 steps, 3 passed. So this is effectively saying there was a 100% pass rate for this particular run. If we now have a look at the first few lines of code, what actually happened? So what happened was we printed out the statement, executed the navigate to zoo method, followed by the click to adoption link, and finally followed by the check no animal string was visible or not. So that means our steps now certainly pick up the methods. So our steps are now definitely picking up our methods. If we take a little bit more look, we can now see that there's actually more information about the actual feature we run. It's printed out the feature, followed by the description that we gave it. It's printed out the scenario and the steps in order, and it's printed out exactly where those steps were found, in what class, what the name of the method was. This is why I changed it, because it just makes almost more well, it's easier on the eyes to actually read, as opposed to if it had been I underscore navigated underscore to underscore there, and so on, so on, so on. So what have we learned? Well, in this video, first of all, this video wasn't as technically heavy as the first one, but comparison, I think we've learned a lot more from this than from the first. But anyway, from this video we learned a little bit, well, a lot more about the purpose of the runner class. Well, I hope you have. We've definitely learned a lot more about the feature file, the kind of rules that are governed, what this means to who, and we learned how to actually write step definitions and how to map a step definition to a step in a feature file. We also picked up well, what I like to say is some good advice on how to generate these methods for us without us having to kind of do it ourselves. Naturally, if you think it a bit hardcore, then yeah, go for it. I usually write my own steps, but you know, once you've kind of written a scenario with about 20, 30, 40 odd steps, it can become a little bit tricky to try and kind of negotiate between the number of steps you've written, the number of step definitions you've written. It's just easier just to run everything once and just copy paste. Well, one of my policies is if it's not broke, why fix it, right? So if Eclipse is willing to help us do something a lot more easily, then yeah, use it to your advantage. Go ahead and do it that way. And finally, we just proved, just by printing out the statements, that our feature steps are certainly talking to our step definitions. And the last thing I'd like to say is we've written all our step definitions in this one step definition class. If we were to write, let's just say, many more feature files, so let's just say we had about 20 different feature files. So in fact, let's do it. I'll just create a duplicate feature file. Right. And I go in there. And let's just say we had let's change these for a bit. So I navigate to the zoo website. So this time, instead of clicking on the adoption link, I'm just going to click on the about link, and then I won't do a check. I just want to keep this a bit simple, and I run this. What do you think is going to happen if I run this now? Well, obviously I don't know what your answers would be, but this is what would happen. When it tries to run this step, it'll be fine because this step exists in the step definition already. However, this step doesn't. This is a brand new step. This is different to the adoption step. So let's run this and let's see what happens. There you go. So from top to bottom we said executed the navigate to zoo method, but however the scenario in its kind of entirety was undefined, and it's undefined. The full scenario is not fully defined, so it ended up with an undefined, and it knew there were 2 steps in total and 1 passed, i.e. the first step, and the second step didn't because it was undefined. And the reason it's undefined is, yes, you've guessed it, the step doesn't exist in the step definitions. So if we now just quickly copy this and put it in here, and I'm going to do the same thing. I'm just going to print out a system out really quickly, and let's just say executed the click to about link method. Should click on about. Now if you run it, oh, there were errors somewhere. Hold on, where are the errors? Ah, of course. See, now it was fine. It printed out both steps. Yeah. The reason why I've done this, I wasn't going to actually do this. This wasn't part of my video. I thought it's probably best if I do this. The reason I did this is because I wanted to show we have 2 different step definitions, and both step definitions share some steps, and both we have 2 feature files, and both feature files share some steps, but they also have different steps. So what happens is all our feature files share the same step definition class. And so if we just had all our steps in here, whenever we run a feature, they will all get called from here. Some would say, hold on, this is actually quite bad, because you end up with various steps in one class. It becomes difficult to maintain. No, it doesn't, and this is why. If I copy this step definition, call it 2. We shouldn't name classes with numbers. Definitely never name classes with numbers. But this is just to make things a little bit quicker, I suppose, on my end. And I go in there, and what I'm going to do is, from this one, I'm going to get rid of this given step, and I'm going to get rid of this last when, and from this one, I'm going to get rid of the 2 in the middle. So we now have 2 step definition classes. This has some steps which are in some feature files, and this has some in some. So another way to think of it is both feature files are using both step definitions. So now let's run and see what happens. It was fine, and the reason it was fine is this: whenever a feature file runs, it looks for that given step in any given step definition class. In other words, if that step, the definition for it has been implemented anywhere, go and get it and run it. And that's pretty much what happened here. The reason why you might want to run multiple different step definitions, so this is going back to the very first point when I said let's just make a step definition class for the purpose of this, to keep it simple. The reason why you would have multiple step definition classes is because you might have I don't know, you might have a step definition classes that only has givens and nothing else. So the purpose of that step definition class might only be to help set up tests and nothing else. Why might you do that? Because then you can use various things like let's just say, I don't know, the inheritance. So you can say something like inherit I don't know, common given something. Why? Because you might have, let's just say, like a base class which has various methods which are only, or which should only be available to given methods. For example, if you're writing some kind of WebDriver framework, you might want to be able to say navigate to certain websites, navigate to certain pages, populate certain things as part of a test, and you might write all of that somewhere else. Another way to think of it is you might actually have some logic classes which are separated from your step classes, because you don't want to end up with something like this, do you? You don't want to have something like public void do magic method which does some kind of logic, and then you have various other methods which do various other things, and then these methods are used in your steps. You don't kind of want them in the same place because it clutters up your step definitions, right? But if you were to move them in your inheritance, then this makes life a little bit easier on the maintainability side. Again, some bonus advice, take it if you will, it is free of course. And that's it for this video, folks. If you enjoy my videos and you find that they bring you some new knowledge or insight into writing Cucumber tests, then please subscribe and rate. If you have any questions, as always, please leave a comment below. In particular, if you have any video suggestions, please do the same. Thanks a lot for watching. Until next time, ciao.